Okay, so this question says, welcome. Today Academic Daddy will be teaching you everything you need to know on colligative properties. So this question is on general chemistry. It says the vapor pressure of water at 80 degrees C is 355 torr. Calculate the vapor pressure of an aqueous solution made by dissolving 50 grams of ethylene glycol in 50 grams of water. What is the vapor pressure lowering of water in this solution? Now I need you to know that whenever you're dealing with colligative properties is among the properties of a system where we have an open system, closed system, adiabatic system, and so on. So colligative properties is a property of solution, or is among the properties of solution that depends on the number of particles. So strictly on the number of particles and not on the nature of particles. So when we talk about colligative properties, we have four major types of colligative properties. We have the relative lowering of vapor pressure. That means vapor pressure in itself is not a colligative property. So relative lowering of vapor pressure, we have elevation of boiling points, depression of freezing points, and osmotic pressure. Now before we dive into relative lowering of vapor pressure, which this video is all about, I need you to understand what we mean by volatile and non-volatile. Whenever you hear volatile or volatile solvent, volatile solute, it simply means that it exerts pressure. And whenever you hear non-volatile, it simply means it does not exert pressure. And since we know that solution is equals to solute per solvent, it simply means that anytime we have a non-volatile solute, is as good as saying that the pressure there is zero. So if you know this, it takes us to Raoult's law. And Raoult's law states that the partial pressure of a solution, or should I put it this way, the partial pressure of a solute, because actually it's supposed to be the vapor pressure of a solution, but for the fact that one of it is non-volatile, it makes it look as if it's just the solvent that is in question there. So it says that the vapor pressure of a solution is equals to the mole fraction of solvent and times vapor pressure of solvent, which is the same thing as saying the vapor pressure of a solution is equals to the product of the mole fraction and the vapor pressure of the solvent. So since we know this now, we need to now get back to colligative properties, which is talking about relative lowering of vapor pressure. When we have this relative lowering of vapor pressure, which is what we have here, you need to know that, first of all, how do you lower vapor pressure? To lower vapor pressure is simply adding non-volatile solute to a solvent. So anytime you add a non-volatile solute to a solvent, it means that it will go there and cause that solvent not to exhibit the kind of pressure it exhibits on a normal. So that means that in this case, the vapor pressure of the solution will drop, it will reduce. So that is why we say that lowering of vapor pressure is simply vapor pressure of solvent minus vapor pressure of solution. So if you know this, you now need to know that relative lowering of vapor pressure is equals to lowering of vapor pressure all over vapor pressure of solvent. So, and this is the same thing as having this formula. So now that you know this, you need to know that everything we have here in this formula, anytime you finish solving using this formula, to confirm if your answer is correct, you simply need to go and check by comparing the mole fraction of non-volatile solvents. So comparing it, what this means is that we know that we normally find the mole pressure of solvents, but whenever you solve for relative lowering of vapor pressure, if you want to check if your answer is correct, simply do this equals to mole of volatile solutes all over total mole of solution. So once you do this, the answer you get here, if it does not equal to the answer you get here, know that you are wrong. But if it equals it, you know that you are correct. Which is the reason why Raoult's law is simply states that the relative lowering of vapor pressure is equal to the mole fraction of non-volatile solvents. So the relative lowering of vapor pressure is equals to the mole fraction of non-volatile solvents. I don't know, I think it's better we call it solutes, but you know that once we are taking this to solve, it looks as if we are calling it solvent in this case, but see it as solutes. So once you know this, let's try to solve this question. So looking at this question, everything we have here, I've analyzed it, and it simply means that since they said at 80 degrees is 355 torr vapor pressure of water is the solvent. You need to know that water is a solvent that is volatile. Non-volatile solvents include things like solvents like glucose, sucrose, urea. So now that you know this, we'll now check. We have 355 torr. Vapor pressure of solvent to be 355 torr. Now they say calculate the vapor pressure of aqueous solution. We don't know the vapor pressure of the solution. Now they say made by dissolving 50 grams of ethylene glycol. Now see the molecular formula. Now in 50 grams of water, we've written that as well. So what we simply did is to find the mole of each of them. You know that the mole of a substance or mole is simply given by mass over molar mass. So we now use the 50 gram of ethylene given to us all over the molar mass. When you sum this up, 12 times 2 plus 1 times 6 plus 16 times 2, it gave us 50 gram per mole. And when you do 50 over 50, you are getting 1. That is for ethylene. Then for molar mass of water, we have 1 times 2 plus 16. When you do it, is 18 gram per mole. So that you have 2.778. So when you now want to find the mole fraction you are finding is that of the solvents, not the volatile solvent, but the solvents. So that means the volatile solvent here is water against total mole. So when you do it, we have everything here. Now when you've done this, it simply means that the mole fraction of solvents now, the mole fraction of solvents, which is sometimes written as mole dots or mole degree, so is 0.7553. Now since we've gotten to this stage, we now need to remember that Raoult's law states that the vapor pressure of solution is equals to mole fraction of solvent times vapor pressure of solvent. So sometimes this is considered to be partial pressure, reason being that most of the time the solvent is always against a non-volatile solvent, non-volatile solute, which makes this to just be partial. The other one will be 0. But in this case, you need to know this formula. So if we put this formula to find the solution now, we'll now have that this is the sentence saying 0.7353 times mole fraction of solvent, if you remember. The partial pressure of solvent, if you remember, is 355 torr. So that when you do this mathematics, you now have that this is the sentence as 261.0315. And since the given pressure, please punch your own so that we don't make mistake. Punch your own and be sure that the calculation I have here is correct. So when you check this, I'm getting 261.0315, and since the given pressure is in torr, I'm leaving in my answer in tau. So once I've gotten this, I've gotten the vapor pressure of solution. Now to get the lowering vapor pressure, the relative lowering vapor pressure, you need to know the difference between lowering pressure and relative lowering pressure. Notice that here, lowering pressure is just this, but relative lowering pressure, look at it. So I think the best way to do this is to solve for lowering pressure, then before you solve for relative lowering pressure. So to solve for relative, if you check that question, to solve for relative lowering pressure, we now have that this is going to be the same thing as saying lowering pressure first of all. Lowering vapor pressure first of all is simply equals to pressure of solvent minus vapor pressure of solution. Now see how we got this formula. How we got this formula is that, for example, if we have water, water on its own will exert pressure, but when you now come and add a non-volatile solute to this particular solvent, you see that solute plus solvent gives you solution. So for that reason, it will not exert the kind of pressure that it's supposed to exert. It will drop. So for that fact that it will drop, it has reduced it. So that is why we now have that the solution is carrying minus. This minus means reduction in solution, pressure of solution. So that is how we got this formula. So that if we want to do it now, we'll now check what is the vapor pressure of solvent. It's 355. 355 minus vapor pressure of solution is 261.0315. Now, if you do this very well, you will get your answer, which is around let's punch it. Okay, so whatever answer you get from this is your answer for lowering vapor pressure. But remember that relative lowering vapor pressure is equals to lowering vapor pressure, which is the same as 355 minus 261.0315 all over vapor pressure of solvent, which is 3555. So when you do this now, you get that your answer will be equals to first of all, you're supposed to get here, the answer you're supposed to have here is something of 93, I believe so, 93.9685. So it's the same thing as saying relative lowering pressure will now be 93.9685 all over 355. So that when you punch this on your calculator, please do well to punch yours so that you don't we don't make a mistake. So when you punch this on your calculator, you now have that this is going to be equals to 0.2647, and this is approximately 1. Now see all these things we solved. All these things we solved is to make use of the formula. Please, if you're solving objective question, if it's objective question you're solving, you don't need to solve. Whenever you hear find the relative lowering vapor pressure, all you just need to do is simply do mole fraction of known volatile solutes, which you can call solvents, because whenever you are concentrating on mole fraction, you are thinking of it as solvent, but let's leave it this way, of solute. So you remember that it was added, equals to mole, that is mole of non-volatile solutes all over total mole of solution. So now let's check. Let's check in the question. From what we solved, we remember that mole of non-volatile solute. Look at it. This is ethylene. The mole, we got it to be 1. And the total mole, we got it to be 3.7778. So we are going to put it in such a way that this is going to be 1 all over 3.7778. When you punch this, this will also give you 0.2647, which is approximately, what am I saying? I said is equals to 1 is approximately 0.0, oh God, 0.3. This is approximately 0.3. And remember that since this is lowering vapor pressure, the Tor and the Tor here, and the Tor here is getting cancelled out, and this Tor is remaining. This one is supposed to be in Tor. Now, so when you do this, you still get this to be approximately 0.3. And you know that mole fraction has no units. So whenever you want to get this, you can check your answer using this. That is why it is said that by von Babo, he said that once we know Raoult's law, we can actually quote it now to mean P of solvents minus P of solution all over P of solvent is equals to mole fraction of non-volatile solutes. Thank you. Please like, share, and subscribe.